Okay, good afternoon. So today I'm going to go through the connectors or the model assembly workflows. So this kind of really builds on from a lot of what Greg had gone through from a model build point of view, and this then integrates in the model assembly side of that. So how do we go from parts and subsystems, and how do we join in and make those and join those together as a functional system? So as Greg went through from a representation and revision and configuration management, I don't think he touched on configurations today. But subsystems follow through that same workflow, and then connectors really are trying to build on controls, efficiency, and then again representations. So different ways of representing the same bolts, the same connector, the same spot weld in different situations, and how do you manage that, and how do you kind of ensure you have the consistency throughout your model build and assembly workflows. So really the intention behind connectors is really to manage reuse between parts, subsystems, to efficiently manage the realizations, to make sure that they are organized in the right place at the right time, and again trying to work on consistencies, and then work between how do you want to join your various systems together. So we're going to start kind of from a conceptual point of view. The intention behind connector controls is really to try and help you up front define how you would want to realize your connectors based on whatever situation they happen to be in. So for various different solvers, you might have different situations from a realization point of view. So how do we go from a CAD representation, from a CAD system of a given bolt or a given spot weld or an adhesive line or a seam weld line, through to a representation of a rigid or representation of a 3D element with contacts, one that creates a heat affected zone for your durability or safety analysis? How do we go from one representation to many other various representations of a given connector in an efficient way and a reusable way? So the intention behind the solution from our perspective is the use of controls. So controls are really like a recipe book. So you can upfront define, independent of any connector, how you want your realizations to work. It allows you to give it a user-defined name, so anything that resonates from your side. So you can define it, you can name it whatever you'd like. You can apply all of the different attributes, so diameters, values, stiffnesses, hue formulation if you're doing aerospace type analysis. All of those things you can kind of define and set up through the control file. And then these can be saved independently of any session and automatically loaded into any session. So this kind of breaks through. So this is just an example of what the control manager looks like, but on the left-hand side in this image, it's now the right-hand side in later versions, you have all the attributes assigned to a particular control, and then it's organized per style of connector that we effectively have. So a tab for fasteners, a tab for line connectors, a tab for point connectors and attachments and that sort of stuff. So what does this look like in practice? So in practice, I can go to my control manager, it loads up, I can right-click create to create a control. I've got my list of all of my available realizations for a given solver profile available to me here, so I can select one that's appropriate for what I'm trying to do. They can be duplicated, they can be named, you can set parameters and whatever you want to do from that side in the control up front. And then again, this is just jumping through the different control styles that we currently have. So these are the different connector types. Now each of those tabs corresponds to what you see in the ribbon. So you define one for a point, it's available in the point ribbon. You can load in pre-existing controls, so in this case, I've got a file that I've already set up where I've got given realizations for different solver profiles. I've got realizations for aerospace applications with different Young's modulus for the hue calculation potentially, different diameters, and that can be saved as a HM binary file and live somewhere on potentially within, if it's your own file or if it's something that a team has, can sit on a shared drive somewhere. If I go into the preferences, I can navigate to this particular file and I can say automatically load. So now if I clean my session or I load in any given model, in this case it's a very complicated 3-plate model with some holes in it. If I go into any of the contexts and I go to create a connector, you can see at the moment we have no controls listed. click undefined, all of my controls are automatically loaded for me. Which means that anytime you go into any of the contexts, if you've got this defined and upfront, you can have all of your controls available to you, all of your connector definitions available to you, independent of any connector before you've effectively created anything. So now we've got kind of the concept of how controls works as an upfront definition. What does that look like in practice? So in this particular context, I've got some solid geometry representing a weld on a frame structure. I go into lines, I select my solids directly. That's not available in the old user interface, it's only available in the new user interface. My controls are automatically loaded, I select the realization style I'm going for, and I click realize. And that's it. That's kind of now the only process that, from a setup point of view, that's required. Within the control for this particular realization style, you can define all of the things like how you want your heat affected zone calculated, what size do you want your welds, what size do you want your properties for the welds, what's the calculation methodology. All of those things can be done up front, and the angles for these particular ones can be defined within the control. So again, you can go best practice from your analysis point of view in a very, very simple number of steps, and this historically wasn't previously a usable or a workable really solution. Let's say I want to change the representation, or I want to edit from what was in CAD. I can go back in, I can select the new control style. So in this case, I'm changing to a completely different representation, and I can click realize. The connectors are unrealized, the heat affected zone is removed, the new definition, the new pitch, the new weld is re-imprinted on this mesh, and I should end up with a completely different representation. So in this case, I've gone from a quad with a heat affected zone to a simple rigid imprinted directly into the mesh. Now, if I'm not particularly happy with the definition here, I can go in and I can trim this realization, and I can edit the connector, I can change its position, you can make whatever changes you want to make to the particular realization this way. And again, because I'm live editing, it will undo the imprint, adjust the mesh again, show me where it's going to project to. So those little black lines are the pre-projections, effectively giving you an indication of what it's going to connect to. And then once I'm done, I click realize and it re-imprints. So for this case, I want to go, actually, you know what? I want to go back to a different realization style. I can go back in, I selected my new realization style, I click realize, and it redoes the imprint. And it applies the same control back into a different situation. So the intention really behind controls is to take the burden of setup off, allow it to be managed centrally so that everybody working on the same type of analysis, using the same type of connectors and the same type of realizations, can do this at a one-time process and then apply it again and again and again and again and again, n number of times to n number of models. It's really kind of the philosophy of what we're trying to get to. Building in with what Greg had presented earlier, so well, now this is kind of really kind of stepping up a little bit in terms of what we can do in terms from a model assembly point of view. So in this particular case, I've got the same model that Greg had previously. I'm going to generate a connector on a given spot weld. Now, for example, if these spot welds were instances of each other, I can organize the connector back into the part hierarchy, as Greg was showing earlier with the instancing. I can organize this connector back into the part. I'm going to delete the solid because I'm no longer interested in the solid. I've abstracted the solid into a connector. I'm going to save the representation of this part now as a connector representation. So representation save. I change the representation to a connector type representation and I save it. And because all of these are instances, I can now instance sync all of these parts to now be connectors. So once this is finished, the instance sync operation, when I zoom back out, we'll see all of the solid geometry has now been updated to connectors. So if you have a part hierarchy and you can leverage the part hierarchy for connectors. So for example, if I have CAD and I have a connector representation saved as a function of that part, and the CAD changes, across my body in white, for example, you can find which connectors need to be updated and which connectors I can reuse if the part hasn't been re-updated effectively. So it's really trying to leverage everything that Greg showed from the model build workflows. We can kind of leverage as much as we can from the model assembly side. I don't think Greg went into configuration management, but again, this really again tries to leverage a lot of the work that's gone in from a model build to the model assembly side. So if you do have different representations of the same body in white structure, and you have different configurations of those body in white, what we can do from a connector side is work out what is currently active and what is currently inactive based on the links, and then make those connectors active or inactive based on the configuration change. So in this particular case, if I organize my parts into part configurations, when I update my part configurations, the connectors will prompt saying, I know 200 of you, 200 are now available, do you want to realize them? In this case, I'm saying no for the sake of the video, but if I've got the appropriate controls applied to the connectors in the appropriate places, then you can very easily update and change configurations on your given body and white structures with your connectors re-realize and write out your new body and white. So the intention here is to really, again, build on a lot of everything that was done for on the model build side for the model assembly as well, to try and make this as seamless and as integrated as possible. I think I've got a couple of minutes left. Yep. So a couple of workflows that you might not necessarily, I haven't touched on for this given at the moment is any of the absorb workflows. If you do have models that don't have connectors and you do want to create connectors, all of those tools are available directly under the create. So create is here. Those are the absorb workflows. So in this case, I can go to absorb. I go ACM general, so that's the type of realization I'm trying to absorb, and I just click absorb. And that should go through and identify, I think it's about a couple of thousand connectors within this model. And then create, yeah, so 5,000 connectors are created. And again, in my front subframe, I've got a series of seam welds represented by rigids. I can go into my line, I select 1D seams. We've got a couple of different options depending on what you're trying to do, and then absorb. And it's the same process. So if you do have models that don't have connectors and you do want to create connectors to try and leverage and change controls and representations and all of that sort of stuff, there are mechanisms available to you to try and regenerate or take a best guess approximation at what the connectors are in your model. You just kind of have to know what you're trying to create or what you're trying to absorb, and we should be able to absorb it. So in this case, if I zoom in, we can now see that there's a seam connector connecting between these two parts. So I now should be able to select any of these and unrealize, and the representation goes away. The last thing that we've got as well that might be of interest is all of the auto tools. So if you are in early concept phases and you don't particularly have any representations of your connectors, so there's nothing from CAD, anything from that side, we've got tools available to you to try and, again, make a best guess approximation of where your connectors should be. So in this case, we've got auto point. This will try and create connectors on flanges, so spot welds, rivets, that sort of thing. Fastener will try and, the auto fastener tools are available in 2022.3, so that's coming up soon. But these should then try and find holes and pair holes together for you and then create fastener connectors within those. And then the line connectors, again, are if you've got welded structures and you want to create line connectors, seam welds, that sort of stuff, we've got tools to try and, again, take a best guess approximation of what, based on mesh or geometry, to try and generate the connectors for you. And that's all.